Observational studies versus designed experiments. Once a research topic is developed for a statistical study, the next step is to determine how you're going to answer the question, that is, the question that was posed in that statistical study. There are two methods for collecting data for this purpose. The first is observational studies, and the second one is a designed experiment. So we're going to look at which of these is better and how they differ. An observational study measures the value of the response variable without attempting to influence the value of either the explanatory or the response variables. The behavior of the individuals is observed without trying to influence the outcome of the study. So no implement of change has been involved in the situation, okay, or introduced in the situation. In a designed experiment, this is when a researcher assigns the individuals in the study to certain groups, intentionally changes the value of the explanatory variable. For example, you give one group the medication, another group a placebo, and then measures the value of the response variable as a result of this change. Did their acid reflux improve with the medication? Did it improve with the placebo? And so on. Let's determine in our next examples here whether or not the study depicts an observational study or an experiment. Okay, so keep in mind they're going to be an implement of change has to be introduced into there to be an experiment. So rats with cancer are divided into two groups. One group receives 5 milligrams of a medication that is thought to fight cancer, and the other receives 10 milligrams. After 2 years, the spread of the cancer is measured. So this would be an experiment. The explanatory variable would be the different medications, and the response variable would be the spread of the cancer. Number 2. A poll is conducted in which 500 people are asked whom they plan to vote for in the upcoming election. This would be an observational study. You're just asking a question and observing or writing down what the response was. Okay? While shopping, 200 people are asked to perform a taste test in which they drink from 2 randomly placed unmarked cups. They are asked which drink they prefer. So this is an experiment. Okay, we didn't just watch these 200 people and see what they selected off the shelf and collect that data. We actually gave them 2 different types and asked them which they preferred. All right, conservation agents netted 250 largemouth bass in a lake and determined how many were carrying parasites. This again is observational study. Okay, they did not do anything to influence the amount of parasites that were present. Well, which is better? Okay, first we need to consider a few things about an observational study. Confounding in a study occurs when the effects of 2 or more explanatory variables are not separated. Therefore, any relation that may exist between the explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. For example, in your textbook you read about senior citizens getting the flu shot. Okay, they studied that over 10 years and saw that the ones who did get the flu shot had less instances where they developed pneumonia or where they died or where they were put in the hospital versus the other group. Well, what they did not consider in those groups were different variables that could have affected that same outcome that was not just a flu shot. For example, what was their health to begin with? How lively were they? How well did they get around? How mobile were they? Were they able to do things on their own? What economic group they were in? What gender were they? So there are other variables that could cause outcomes that you may think was the actual variable you were studying when it was something else. Okay, so it's potentially a major problem with observational studies, and it can often cause confounding, can often cause what we call a lurking variable. And these are explanatory variables that are not considered in the study but affect the value of the response variable in the study. In addition, lurking variables are typically related to explanatory variables considered in the study. For example, we were looking at the age group. Well, it could also be their well-being. It could be their gender. It could be their economic status. Okay. Designed experiments are used when control of certain variables is possible and desirable. This type of research allows for a cause and effect relationship among variables in the study, whereas observational studies only allow us to claim an association between the variables. We can't say this variable caused this outcome. Okay, but we can say that in a designed experiment. We use observational studies often when it would be unethical to conduct an experiment. For example, you would not want to conduct an experiment trying to link smoking to lung cancer, or trying to link power lines to leukemia. Sometimes we are able to do experiments when we actually use a simulation. Okay, if we wanted to test the effect of wind shear on an airplane, then we could do a simulation for that instead of an observational study. We could do that type of experiment. Okay, observational studies also have other advantages over designed experiments in that they're often lower cost, they're quicker to perform, greater in timeliness, and there's a broader range of participants, so we can generally get a larger sample size when we're dealing with an observation versus an experiment.